Tonight's lesson is on proportional relationships. I'm hopeful by the end of this lesson you'll be comfortable analyzing if two ratios are proportional to one another. You'll continue to work on your skill of solving real-world and mathematical problems that involve ratio and rate. And finally, you'll continue to work on computing unit rates. First thing I want to talk about is what it means for two quantities to be proportional. In this example, we'd be asking, is weight proportional to cost? Well, weight is proportional to cost that happens if you have your weight and you're able to find some constant value to multiply each weight by in order to get the cost. And if you can find a single value here so that each time you multiply weight by that value, you'll get the corresponding cost, you know you have a proportional relationship. 2 times what is 6? Well, 2 times 3 is 6. 4 times what is 12? 4 times 3 is 12. 6 times what is 18? 6 times 3 is 18. Because every time we have our weight, we're able to simply multiply by 3 and get the cost. That means that, yes, weight is proportional to cost. It just means there'll be a constant value that you're able to multiply by each time. If you had a hard time coming up with that 3, and in this case we probably didn't, but if it had been a fraction or a decimal, it may have been harder to find that value. What you can always do is take your second quantity, in this case cost, and divide by your first quantity, in this case weight. So I'm just going to take one of the costs. I'm going to choose 18. I'm going to divide that by the corresponding weight by 6. 18 divided by 6, fraction bar means to divide, is actually 3. And that would give you the value that you could try out multiplying each weight by. Next example I want to look at is lining up several tables end to end for a party. Is the relationship between the number of tables and the number of chairs proportional? Well, what I have here is I've decided to set up a table of values just to organize my information. Blue represents our tables, so for one table, the red represents chairs, you'll need 4 chairs. If I was going to push 2 tables together, I'm going to need 1, 2, 3, 4, 5, 6 chairs. 2 tables is 6 chairs. I already see there's an issue, so I'm not going to go any further. As soon as I look at this and I say, 1 times what gives me 4? And I say, okay, 1 times 4 gives me 4. If this had been proportional, I would have also been multiplying 2 by 4. But that would get me to 8. In this case, to go from 2 tables, you multiply that by 3 to get the 6 chairs. As soon as these two values do not match, this is not a proportional relationship. So the number of tables is not proportional to the number of chairs. There may be a relationship, but it's not a proportional relationship. This is the first example I'm going to have you try on your own after we read it over together. During John's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average would be burned by completing the activity. So here's the chart. It says calories burned while jumping rope. And so for instance, if you jump rope for 3 minutes, you burn 33 calories. It says, is the number of calories burned proportional to time? How do you know? I need for you to take a moment, try the problem, pause the video, then come on back. Okay, hopefully you tried the problem on your own. I want to take a look, and what it means to be proportional is that I'm going to be able to find some constant, some number, that if I multiply each of my times by that value, I'm going to get the corresponding calories burned. So I have to say, 1 times what is 11? Well, 1 times 11 is 11. So now I have a value to try. Well, what's 0 times 11? Hey, 0 times 11 is 0. What's 2 times 11? 2 times 11 is 22, 3 times 11 is 33, and 4 times 11 is 44. So since we were able to multiply each of our number of minutes by 11 to get the corresponding calories burned, this is proportional, totally a proportional relationship. And what that means is that you can always take each of your times, multiply by 11, and you're guaranteed to get your calories burned. Absolutely guaranteed to get those calories burned. If you had a hard time coming up with the 11, you can always just take your second quantity, in this case calories, divide by your first quantity, in this case time. And so I just picked one of my calories. I picked 44. I could divide that by the corresponding time of 4. 44 divided by 4, use your calculator if you need, is 11. And the reason you do that is if you're having a hard time figuring out what number to try out, that's a quick way to come up with it. So, totally a proportional relationship. Time is proportional to calories. Same scenario. Now I want you to try the problem and see if John jumped rope for 6.5 minutes, how many calories would he expect to burn? So I need to go ahead, pause the video, try it out, come on back. All right, so let's see. I might just continue on my chart. And I'm going to take a look at 6.5 minutes. I saw that every time I wanted to go from number of minutes to calories burned, I simply multiplied by 11. So I could take my 6.5 times 11. On my calculator, I'll take my 6.5 times 11. And you're going to get 71.5. 71.5 calories burned. And there you go. Excellent. I wonder if you're starting to realize what this number is here that we multiply by every time. This is 11 calories per minute. All that means is that every minute you're burning 11 more calories. So I want you to just kind of be thinking about, what does that 11 mean? We've learned about it already this year. So be thinking about it. What is that constant? What does it mean? Next example. A new self-serve frozen yogurt store opened this summer that sells its yogurt at a price based upon the total weight of yogurt and its toppings in a dish. Each member of Isabel's family weighed their dish, and this is what they found. I'll just give a for instance. One of the family members went up and they weighed their yogurt. It was 10 ounces, and they found that it cost $4. Is the relationship between the number of ounces and the cost proportional? So what I need for you to do is I need for you to take a moment, pause the video, try it out, see if the cost is proportional to the number of ounces, and come on back. All right, hopefully you took a moment and figured this out. First of all, you would try to just come up with a value. And you'd say, okay, what could I multiply 12.5 by, 10 by, 5 by, 8 by to get the corresponding cost? Well, I'm going to tell you, this one's not as easy to come up with, is it? Because this one is not a whole number as the other cases. This is actually a decimal or fraction you're going to have to multiply by. So it's like, I don't know what I have to multiply 10 by to get 4. I could use the strategy of taking the second quantity, dividing by the first, ounces, to come up with the value to try out. So I'm just going to choose this example right here. So I would do cost divided by ounces. So I'm going to go ahead and do 4 divided by 10. 4 divided by 10 on my calculator is 0.4. Make sure you put the 4 in the calculator first, then hit divide, then the 10. So that tells me I'm going to try out 0.4 and see if each time I multiply the ounces by 0.4, I come up with a corresponding cost. Let's take a look. 10 times 0.4 is 4. That one we knew would work out. 12.5 times 0.4, it's 5. 5 times 0.4, I'm so hoping it's 2, and it is. 8 times 0.4, let's hope it's 3.2. 3.2, yes, this relationship is completely proportional. And I know it's proportional. If it says, how do you know? You tell them, because every time I take a weight, I simply have to multiply it by 0.4 to get my number, or to get my cost. weight times 0.4 gives you your cost. And as long as there's a constant value that you're able to multiply that first quantity by to get the second quantity, it's proportional. The next thing I'd like you to try to do is come up with the unit rate. I'd like you to try to come up with the cost per ounce. Some of you throughout this video have seen a connection between what we multiply each of the first quantities by to get the second quantity and your unit rate. So hopefully some of you see a connection. If not, you just go ahead. We've been working on how to find a unit rate. Try it out. Pause the video. Come on back. All right, so for some of you, you said to yourself, well, if I multiply by 0.4 every time, what that means is it's 40 cents per ounce. Some of you have already seen that connection. Whatever number you're multiplying by, that actually is just your unit rate. That's all that it is. But if you didn't see that quickly, that's okay. If we want cost per ounce, that means we want cost over ounces. Cost per ounce. Well, I can choose any one of them. I'm going to go ahead and choose the 4 and the 10 because why not? So I'm going to go ahead and choose $4 is 10 ounces. I want cost per ounce. That's the unit rate. That means I want the cost for just 1 ounce. That gives me my unit rate. So here I say, okay, look at my denominator. What do I do to 10 to divide down? I divide by 10 to get to 1. Whatever I do to the denominator, I must also do to the numerator. 4 divided by 10 on your calculator is 0.4. But never would a clerk ask you for 0.4 of a dollar. They won't say, oh, it's 0.4 of a dollar per ounce. No. You have to put that zero placeholder in so you understand that it's actually 40 cents per ounce. And there you go. That's your unit rate. All right, still related to this problem, let's say Isabella's brother takes an extra long time to create his dish. When he puts it on the scale, it weighs 15 ounces. If everyone pays the same rate at this store, and we just discussed what that rate is, 40 cents per ounce, how much will his dish cost? How did you calculate the cost? Pause the video, try it out, come on back. Hopefully you pause that video. I might just use the equation that we talked about. Each time we take a weight, we multiply it by 0.4 or 40 cents per ounce, and we get our cost. Several ways to go about this, but this is just what I'm going to do for now. So if I know my weight is 15 ounces, I'm going to go ahead and take 15 times 0.4, and I'm going to come up with my cost. So on my calculator, 15 times 0.4, and I find it's $6. So Isabella's brother's yogurt costs $6 for those 15 ounces. Here's your focus question that I need for you to go ahead and answer and be prepared to share in class tomorrow. What does it mean for two quantities to have a proportional relationship? How do you know the relationship is proportional? And how can you tell if a table of values shows a proportional relationship between two quantities? So I need for you to go ahead and try to answer those questions. Bring them to class tomorrow ready to share. Have a good night. Thanks.